we did. We started integrating some of those design elements into the design Roundabout design guide, and so here's a detail on that. And they have a lot of benefits as far as like lane discipline and addressing some of the challenges. Again, another good aspect as far as us waiting as long as we did was there got to be more research on the geometric causes of why multi-lane roundabouts sometimes have high crash issues. Mainly PDOs, so they're still not getting severe crashes. But what are the design elements that are common, that are seen in high crash multi-lane roundabouts? And so we were able to bring these elements because those lane discipline issues and path overlap and things like that we're seeing as some of the big problems. Here's an example of one that's shown in my first example. The first example is kind of like an early. We were sort of looking at it before we started developing the in-lane turbo elements. In this case, it was just a longitudinal, like in the tangent section before you actually got into the entry curve. And but without the raised elements, what we were seeing, the way you would have to design to get the speed control that you need entering a multi-lane roundabout is you would you wouldn't get the speed control, or you would have to create such a curved maneuver, a curved entry to kind of hang up the driver to keep those speeds down. And what that was causing is some kind of geometric challenges as far as path overlap, and you really by the time you say you're bringing them right to really come back to, or bring left to come back to the right, and to the point where it's really kind of a skewed entry, and it's not always clear as far as like lining you up into the entering lane. So this is the simple addition of the raised divider. In this case, basically it keeps the driver's path, keeps them from being able to enter and cross that that line, which is typically seen in kind of like off-peak periods, but it really forces them to stay in that outside lane, and it helps kind of provide positive guidance to keep them in lane as they're entering. Another good thing about this is actually because when you're talking about had those tight entry radiuses, it's compounded. Didn't really get into really explaining what a spiral, but a spiral entry is something that's also something we're kind of adopting as well, which is again more doable because of the raised elements that they the biggest benefit being that, again, you see this is a standard multi-lane roundabout without raised elements and without any spiraling, and just the way you have to design it to get the entry speed, you end up with these really long conflict zones. So the person in the outside lane has to drive nearly 100 feet or more to get past the point where the inside lane on the exiting on the exiting inside lane, they're crossing right over here in this point, and that's such a long distance to get to, and trying to judge that as a car's coming around the roundabout and as a driver is really difficult. So when you're introducing the raised elements along with the spiral, you're really able to tighten that distance up because you don't need to have this kind of steeply angled entry. So you're able to get in and get across much faster. As so you get the drive, the inside drive exiting lane is really nearly halved. So there's some really great elements to that that are introduced both by the raised elements and by the spiraling. Poor lane guidance is another issue, where we have you have two entering vehicles, and there's really nothing geometric that kind of indicates to the driver that they're not able to continue around the roundabout in a traditional two lane, because it's just a big circle. You can kind of reinforce that with some striping and things of that nature, but again, it doesn't seem as unusual as a movement as it should be, really, because it's not something that people should be doing. And even worse, we have some hybrids. This is one in Roswell, which has actually been converted to a single lane at this point. But But we have some other ones like this that the maneuver itself is enforced. You have an outside lane that is actually a left turn. So we're establishing that driver behavior, and then so then when we move to a full 2x2, which is never going to be a situation where you want that maneuver to happen, then it just kind of leads to problems. So again, introducing those lane dividers, and in some cases the spiral elements. You really provide a much better guidance, for the driver as far as, you're in this lane, you see these barriers, and you see the path that you're allowed to go. And there's really, there's really, you're coming into this outside lane, it'd be a pretty big jump to assume that, going from here and continuing left through the roundabout would be something that you're supposed to do. All right, and then moving on into our first example, or our first case study. This is up in Walton County in District 1, State Route 81 at 138. This is I think the design volumes were 38,000, and so we really had no choice but to go into a full 2x2. We had a lot of constraints on the site as far as and it was already a signalized intersection, so there was a lot of reasons why it made sense to go to move from a signal to a roundabout. But when we got into the design, again, with traditional 2x2s, we were seeing some of the same issues, which were even further compounded by the skewed intersection. So, like I was saying, those long crossing distance were on this obtuse leg. I mean, again, I think it was closer to 150 feet that the car would have to travel before it was actually in the roundabout. So trying to gauge that as you're entering there and saying, how long do I need from that, that driver is coming around the roundabout? Do I have enough time to get way the heck over there to cross his lane? And then really, so this is all one alternative with the traditional circle design, along ellipse design, which actually made the issue worse. It corrected some entry speed issues, but some other problems. A short ellipse as well. And again, there really just didn't seem to be a solution of a traditional roundabout design, multi-lane roundabout design that made this a viable alternative. It was, we could see the writing on the walls. This was going to be one of those roundabouts that was going to be a problem. So what we ultimately came up with, which is something that I've really been pushing because I like the name, the super spiral. It's like my fetch. If you've seen, Mean Girls. But we're sticking. Okay, this is sticking at some point. So essentially, the idea is, we're going to do a spiral entry on all four legs, raised elements. In this case, this was kind of before we really started going full turbo mentality with raised elements in the roundabout. So you see buffered areas inside the roundabout. They're actually they're grounded rumble strips with kind of widened, so we get a lot of the benefits, but not quite the same benefit as full raised elements throughout. But yeah, it's. You do have the raised elements on the entry, so again, you kind of flatten these entries a little bit and maintain that speed control, because this is the raised element right here. So if you were in this lane without this, you could just cut across here and enter the roundabout at substantially higher speeds. So that helped greatly with both crossing distances, entry speeds, just by introducing those raised elements. Moving on to our second example is actually in my District 6. Up in Bartow County. This was an interesting one, and probably, and for an interesting reason, is probably going to be the first one that gets put on ground, in the ground with full raised elements. The project actually let for construction in 2020. So it's been hanging around there for a while, and it's a big project. It's basically a Cartersville South bypass, and so 4-lane divided, a lot of new location, and at the time, back in 2022, we're getting pretty far into construction. We're doing bridges and whatnot. We still have we're still fairly early in the construction game, because construction takes forever. And my predecessor, Christina Berry, who you've seen quite a few times today, noticed that one of the intersections was going to be a problem. It was a very typical situation we've seen in multiple bypass locations. You have a state route, or sometimes not always a state route, but a fairly heavily traveled local road or state route, and and typically it's a kind of people just go 55 miles per hour, and you're just blowing through, and then we come in and throw up a 4-lane divided highway right in the middle of that and create this intersection where everybody's used to just booking it through there and not stopping, and they feel like they have the priority. And a lot of times, to make it matters worse, is a lot of times we open up the 4-lane divided. It's not heavily trafficked, so people kind of feel like a lot of times they can just go in there and keep going. So it's not going to meet signal warrants, and it's going to be dangerous. So so she asked the design the Ray group and Barge to look at some alternatives, and luckily there was some and maybe unfortunately there was some groundwork that was done, specifically Gray Bypass in District 2. Or something similar. It was not designed to be a roundabout. It was converted after a couple of fatalities happened. But we were able to get ahead of this one, and it was a similar situation. But we got Barge to look at introducing a roundabout where the side street stop was originally scheduled to go in. But you're 2 years into construction, that can be kind of difficult. Because right-of-ways. The right-of-ways bought. It's a construction site. Not to mention, everybody hates doing change orders and SAs. But so Barge had a lot of work ahead of them as far as keeping the roundabout within the existing footprint and not allowing any right-of-way changes. And we'll get to the pictures here in a second. But another issue was that this intersection was going to be right at the end of an airport runway, and I really don't know exactly why, but the road they were planning on expanding the runway or something like that, but the road was about 20 feet below the end of the runway, so it was down in this deep hole. So you have really steep grades on all sides and stuff. So trying to fit this in there was a really big challenge. Needless to say, Barge got it, and we're able to make it work, and it did a really great job. And this is what they came up with. It'll be a 2x1, but like I said, it'll have those raised elements. So we'll right from the get-go, we'll have that kind of positive lane guidance and entry speed control that that hasn't traditionally been associated with multi-lane roundabouts. And now basically I have a couple pictures for you. There's that hole. It's kind of hard to get a sense for how deep that is, but yeah, it was a bit of a hike to get up there, about 20-25 feet up. So this thing's down in the hole, and this is 2025. This was like last week, so project's humming. And a couple of renders of what it'll look like as we finish up with it. But I think it's going to be a great roundabout, and really happy that we got something in there, before the bad stuff happened. One more here. All right, and that's all I have. I think we're going to do questions at the end. So, Simon.
Thank you, Chris. Thank you, Chris. I appreciate your presentation. I honestly did not know that you're going to include the roundabout in Roswell, which is doing great. I defend it. Now that it is a single lane, of course. But yeah, that roundabout really deserves to be spotlighted on a group like this. So if it's not working, do something about it. And I think there's a lot of locations that are like that. Anyhow, our next presenter is Katie Mills. Pedestrian sight distance at roundabouts exits. Katie graduated from Georgia Southern University with a degree in civil engineering. She is a registered professional engineer in Georgia. She began her career with GDOT, working in the Office of Roadway Design for 2.5 years, and has been with Kimley-Horn for 4 years, working with local municipalities as a roadway design generalist. The last 3 years, she has focused on alternative intersections, including traffic studies, conceptual design, and GDOT PDP. Let's give it up for Katie. Thank you.
Hi, everyone. So I am going, if I can get this to work. I'm not sure it's not letting me click anything.
Yeah, it is sabotage, really. Let's do, here comes the boss. We opened and they were ready to go, but
Oh, that's fine.
whatever error it
Yeah, I can see the presentation. Okay. What should do?
You didn't know where to go.
It looks pretty normal to me.
Yeah, if you could find that error and it's okay, that should work. It doesn't show up.
Mm-mm.
All right, take two. So I'm going to talk to you a little bit about pedestrian sight distance at roundabout exits. We're going to talk about the coupling of two issues. So exit crossing sight for the pedestrian and exit geometry for the driver. So a little outline, we're going to look at a case example that could happen anywhere. We're going to look at some NCHRP 834 research, and that's just crossings at roundabouts, and in NCHRP 1043 guidelines, so that's the roundabout guidelines. We're going to talk about exit crossing visibility at curved and flat exits, the presentation of a possible new standard for exit crossing sight for the pedestrian, and then we're going to look at some research problem statements. So we're going to start out by taking just a little walk at this roundabout right here. So we are the little person at the bottom of the screen, point A, and we're trying to get to point B. So we're walking, we're maybe looking at traffic, seeing what's happening at this roundabout, and then we get to our first crosswalk here on the entry leg. We're looking left, we see a car, they see us, that's great, we cross the crosswalk, and we get to this second crosswalk on the exit leg. So we look this time to our right and we don't see anything coming, so we start to cross, and at this point we see this yellow car coming towards us, and it could result in a collision. So why did this happen? Let's look at the central island features of this roundabout. So this roundabout has a wall in the central island. We've got some signs on the splitter islands that could be blocking our view. So let's look at some of these points a little bit closer. So point one, we're at the entry leg and we're looking, we might be looking at the entry leg on the opposite side just to kind of see what traffic is doing. This isn't a critical viewpoint. Our critical viewpoint is the other direction to see what cars are coming, but we might just want to get an idea of what the traffic is doing. So at that point, standing on the ground, we can't really see anything. That central island is in our way, but you know, that's okay. We're gonna go ahead and cross. So now we're at point 2. And point 2, we're looking at that entry leg on the upstream entry. And from what we can see here, we cannot see the inside lane. It is covered by that wall and that sign, and the outside lane only partially visible. So we decide to walk. We've got to cross the road. We're at point 3. At point 3, we can kind of see some of those lanes now that we're standing in the middle of the road. But just to note here, vehicles traveling your fastest path on the exit will move from the inside lane to the outside lane, kind of cutting those corners. So point 4, we've crossed the roundabout. We're out of the way of any traffic. And at this point, this is where we can see everything. So kind of after we've already gone through. So are we missing a design check here? We're looking at, can entering vehicles see circulating vehicles? We're looking at, can entering vehicles see pedestrians at the crosswalk? What we're not looking at is, can pedestrians at crosswalks see approaching vehicles? So as I mentioned, NCHRP and 834, some of the relevant quotes from that, drivers yielded frequently to pedestrians waiting to cross the entry lanes, but significantly less so on exit lanes. Generally, a higher observed noncompliance at the exit leg points to a potential sight distance concern for drivers exiting the roundabouts. High vehicular speed has been linked to a low probability of yielding through research, and the proposed free-flow speed model therefore represents a reasonable approximation of the expected free-flow speed. So when we're talking crossing sight distance is introduced as the distance required by pedestrians to recognize the presence of conflicting vehicular traffic and determine crossing opportunities. Adequate crossing sight distance assures that a pedestrian can identify vehicles far enough away to provide sufficient time to cross the road. Entering traffic is decelerating as drivers approach the yield line and circulatory roadway, while exiting traffic is accelerating as drivers exit the roundabout. So to calculate that distance, we would want crossable gap and the exiting driver's speed. So that kind of comes together to this equation here, which is an estimation of crossable time from HCM gap opportunity model, and it calculates TNC, which is critical headway required by a pedestrian crossing a specific traffic stream depending on number of lanes and lane width. So bringing that together for the roundabout here, we want 2 speeds for this. So according to the NCHRP 834, one of them is going to be your R2 plus your acceleration. So that's for the through path. And then the R5 for the right path. So R2 is your circulating speed, R5 is your right turning speed. So what does NCHRP 1043 say about this? They use stopping sight distance to the exit crosswalk for a right turning vehicle. It's equation 9.9 using that same R5 or right turning speed. So they do not have a diagram for the exiting through movement, and there's no diagram to take in any multi-lane considerations. So that R2 plus acceleration that we saw in the last guidelines, not present in this one. So that leads us to presenting a possible new diagram for exit crossing sight for the pedestrian. So this allows the pedestrian to cross at a normal walking speed with adequate time to clear the crosswalk before the advancing vehicle arrives. So this is the HCM method, but a 3-second startup and clearance time for the pedestrian. This uses the fastest path R1 entering speed, which is more conservative than that R2 speed. More study of that gap acceptance and approach speed is needed at this point, possibly through video analytics. And you can see kind of the diagram here that follows that fastest path, calculating that needed distance along that path. So looking at some variables for exit site definition, what this slide is showing here, this is from data from Sky, so it's some video analytics. The tables are showing us for gate 8 and 9, which is kind of towards the end of that red shape. From real measured speeds in the field, you're looking at 100, 110 feet of stopping sight distance required, where on a typical roundabout, that distance there is going to be about 75 feet. So variables for exit site definition, looking at left offset versus radial design, so curved exits versus flat exits, the R1 versus R2, which one is more needed for that, gap acceptance model versus stopping sight distance, or is maybe a hybrid of those two the right approach? Does the pedestrian need to sight to judge the entire gap for the whole crosswalk, or just to get halfway across? So considering some exit geometry here, on curved exits, you can create a visual occlusion. So what we're looking at in that top picture, those two green cars, as the one on that is more closer to the exit, I'll say, instead of trying to figure out if that's left or right. That as that car is kind of crossing into the sight line of the other vehicle, that vehicle is losing sight of any pedestrians that could be waiting to cross. But those radial exits, those curved exits, generally equal slower traffic. For the flatter exits, both those vehicles, the little purple ones, have optimal sight of that crosswalk, but flatter exits usually equal higher speeds. So let's talk about a few research problem statements. So for NCHRP 1043, crosswalk sight is from the driver's perspective. It is stopping sight distance, currently only using right turns, not circulating, and not considering those through movements. There's no geometric design consideration of pedestrian sight using gap acceptance and crossing time considerations. What would the addition of some ADA and ProWAG accommodations mean for this? What would raised crosswalks, maybe some RFBs, mean in these sight distance calculations? And then the curved exit geometry reduces exit speeds, but creates that visual occlusion versus those flatter exits that were higher speed, but maybe better sight. So which one of those is more optimal for both pedestrians and drivers? That's all.
Thank you very much, Katie. Our next presenters, joint presentation. There you go. This time it worked. Is for Scott Zehngraff and Ola Dimeji Onabanjo, short Ola. Scott retired. So if you know, that's how he wrote it. Scott retired from Georgia Department of Transportation in December of 22 after 28 years, where he championed roundabouts in Georgia, writing the first GDOT roundabout policies, shepherding the first GDOT roundabout projects, and ultimately helping to advance ICE and author the GDOT roundabout design guide. Since retiring from GDOT, Scott has joined the consultant community and now helps GDOT continue to advance roundabouts and other safety projects while working at Barge Design Solutions. And Ola graduated from Florida A&M University with a bachelor's degree of science in civil engineering. Ola is a registered professional engineer in the state of Georgia. Ola's career with GDOT started in District 7 construction, then on to District 7 pre-construction, and currently with the Traffic Operations TMC. Ola joined the RAID team in 2015, then the State Signal Maintenance Office And now Ola is the State Traffic Ops Manager for GDOT and manages the RAID team and plan review programs. Please show a big hand for both Scott and Ola. Thank you.
Thank you, Moj. Want to thank the Georgia ITE committee for putting on this splendid event, and the sponsors for allowing us to have this platform to provide information for everyone to consume. So I'm not Scott Zehngraff, Onabanjo, State Traffic Operation Manager. So I manage the RAID team, and this is our presentation on rural roundabout practical design, guidance, and case studies. Let's see. There we go. So quick overview for our discussion today. We're going to kind of hit highlights about roundabouts in Georgia, the draft changes to guidelines, and our roundabout design guide and details, and then Scott's going to hit into the low-cost case studies, applied lessons learned, and then we'll get into the questions asked, or questions and answer part. So roundabouts in Georgia, we have roughly 175 on state route or built with GDOT funds. 135 of those are single lane, 27 of those are multi-lane roundabouts, and about 13 are mini. And then we also have roughly 50 that's currently under construction, with another 250 that's in the concept or design phase. And then we also have roughly 300 on local roads. So why did we decide to move forward with more, I guess, practical design? And it kind of basically comes down to rising costs. Everything is going up in price, concrete, even landscaping. So, one of the deals is we have to try to do more with less. And so with GDOT, that's one of our best practices, is trying to figure out ways to get safer alternatives out there and with the funds that we have available. So we met with different GDOT internal offices, design policy, road design, district traffic ops, and pre-construction. And so we kind of came up with some goals and outcomes to make sure that when we do make our updates to our roundabout design guide, we make sure we focus on retaining safety for roundabouts, those safety benefits that we come to enjoy, and also include some design flexibility. And hopefully the outcomes would be cost savings. We have less costs with roundabout designs and construction costs, and then faster delivery. The quicker we could get them out into the field and open the traffic for people to utilize. And along with our update, we plan on making sure that we fall more in line with, or aligned with, as well as the updates to NCHRP 1043 and the latest MUTCD 11th edition. So just before we go a little bit more into the roundabout design guide, just wanted to note that there is some guidance about practical design. It's right here, can't miss it, not throughout our whole design guide. But essentially, we took a look back and decided that, we probably needed to provide a little bit more context, give that flexibility so that everybody could kind of understand that certain situations call for certain design features. So that's what we did. So right now we have a draft in our roundabout design guides that kind of goes into that newer or more up-to-date sort of guidance as far as outside truck aprons, where we're probably using either a type 7 or type 9 curb phase. And we typically just want to make sure that those heavy vehicles can be accommodated, and also having the shoulder features out there to make sure that the fastest path or people aren't going as fast as they could. And so rural accommodations, another flexibility that we've also drafted up, is basically if we're in a rural location and there's no McDonald's, no gas station, no residential area in sight. There's that flexibility where, okay, we might not need a crosswalk or something like that, but you have to kind of vet that out with the location and area. Make sure if you're near a school or residential area, you can have, make sure that access is accommodated for. Oh, and just side note, we will be having one last review session for the Roundabout Design Guide. And so anyone that's interested, you can kind of approach us afterwards, but we will be kind of sending a link out to the committee here and making sure that we all get some constructive feedback, constructive being the key term. And also we have our roundabout tool that we're updating as well. So we should be having that one out as well for some key testing. So please be on the lookout for that. And now, just to kind of go into the detail part or updates for that, just kind of want to bring attention to our current detail, which has been around for like 13 years or so. And, it served us well. It got us going. It got us to a good part. But we needed to add more. We needed more information. We needed more context. And so before I give you the next evolution of that, just wanted you to kind of all soak in what we currently have and now kind of compare to what we're about to have. And this is our latest draft of our RA2 roundabout detail. And it has a lot more information than the prior detail. So not to get into details about this detail, we just want to classify this as more of our urban configuration roundabout. So, it has the urban shoulder setting, the bike lanes, crosswalks, and things of that nature. So we're kind of in that classifying stage with this detail. And then the next detail, which is our newest and latest, is our more rural classification roundabout. So this one utilizes the mountable truck apron, monolithic pours. There's that flexibility with sidewalk or crosswalk, no crosswalk. And just to kind of zoom in a little bit further, just kind of showing that there's the monolithic central island, or you can have it with the capped curb and gutter section. So with that, I'll hand the rest over the presentation to Scott Zehngraff.
Okay, so I'm going to go through a few case studies. I'm going to highlight, for the most part, the beginning of this is going to highlight a bunch of quick response projects. Most of us in the audience know what GDOT's quick response projects are, but they have a $200,000 maximum amount to it back before they changed the amount, and they went out to lowest bidder, so it was a really easy mechanism to be able to put them out. Georgia learned a lot of lessons as they're going through these. I'll buzz through them and kind of give you an idea of some of the different key features that we learned from. So this first one is State Route 41. It's State Route 18, or Cedar Arc Road is a fourth leg on it. It's the upper leg is 18 and 41, and then it splits when you go through the intersection. This one was really unique because this area right in here where we had a significant amount of grass island that was out there, I got called out by this is while I still at GDOT, I got called out by the district, and they said, hey, we need to do something here. How can we fit it in? We're trying to fit it in on a low budget. So I was like, well, and I remember going out there with Michael Presley, and we met the district engineer out there and put a stick in the ground and drew the circle of where it would go so they could get an idea of what it would look like. And they bought in on the idea. They liked it. So the Google Earth, we were really lucky, captured the images. You can see here after the bypass had gotten taken out, there was the road that split off to the side, was able to pour the central island and truck apron under construction by just routing it down through the intersection. And then you can see as it goes in, you put in the roundabout itself, and it's a compact size. I think the big thing is that they ended up running into issues on the outsides, and I'll go through that in a couple of slides, where you can see where the trucks were cutting the corners. And so what they started doing is putting in truck aprons on the outside to be able to keep a vehicle from cutting the corner across. They noticed this immediately after construction. They noticed it was going to be an issue, as something we had talked about in advance and trying to decide what the best way to accommodate it was. And so these raised outside landscaped areas that are curbed help that. But for essentially $241,000, the district was able to, a combination of maintenance forces and quick response, not only build the roundabout, but also do the lighting at the roundabout and everything else. And it's 120-foot inscribed diameter. It's been a great project. You can see video here. It shows traffic going through it, including a tractor trailer, and how they're able to be accommodated as they go through the intersection. And this is probably the model type of size and all that. Now, as time goes, it gets harder and harder to be able to stretch the money. This is, of course, back in that 2015 to 2017 time frame. This next one is another evolution of it, 138 at North Mosley. This intersection is 138. You had the school over here on the sides. This school had a lot of traffic come out, so during peak hours, it ended up being problematic when school dismissal was, and they couldn't get out into traffic. They had a cop that was out there stopping traffic and didn't meet signal warrants. So taking the existing intersection and trying to figure out a way to fit in a roundabout at the location. This is a picture of it afterwards. It was a very small mini roundabout, inscribed diameter of about 70 foot. There had been some discussion after it came in about, does it need additional improvements? So the district actually went in afterwards and did a separate project to be able to put in a slightly larger circle. This one's up to 101 foot, had enough room to be able to put in raised portions in the central island. You can see it's street view here, where it shows they've got landscaping and signs in the central island to give it a little bit higher conspicuity. But same thing, it has the outside truck apron on the outside to be able to limit speeds as you're cutting through the intersections, and those make a big difference. So you had two $200,000 quick response projects that happened, one earlier and then one in 2022 to clean it up. And I know I'm going to go through these fast. I want to make sure you guys can get out to the pool or to dinner. This next one's 14 at Hal Jones. This one I thought was really interesting to throw in here. This one, there's two intersections, offset T intersections, that are a little bit away from each other, but both had problems with crashes at the intersections. And it's how could you mitigate those issues at a lower cost? And so District 3 challenged the construction community on what can we put in at these two locations. So they came up with roundabouts at both locations. This one is at Hal Jones, and what they did is essentially took the existing side street stop and were able to put in a roundabout. Once again, the theme of those raised outside blisters to make sure you're getting speed control coming into the roundabout. You couldn't just shortcut the corners. And then just down the way was the intersection of Greentop Road and Greentop Road, same thing, both done in the same project. This one is actually two separate projects, I guess, technically, for funding reasons, but had both by the same contractor, 74-foot inscribed diameter, same thing with the blisters. What's cool about this one is the two intersections, including the asphalt in between and doing all the widening to be able to accommodate it, are only 700 foot apart from each other, but for a total of just under $400,000, we were able to complete the construction of both of them. Just so District 3 is not getting all the love, here's one in District 2. I'm sure our District 2 audience will love this one. So 242 at Waco Mill had a really interesting history to it. You can see on either side you've got schools near the intersection that were routing traffic through this intersection that's out here. The existing intersection back when it was originally put, before 2013 or 2014, it was just a side street stop. But of course, when you look at it, you got stop bars out there. So when you pulled up on the side street, and I remember the first time I went through this intersection, it felt like almost like an all-way stop, because you'd pull up, you'd see the stop bars to the railroad tracks. And so they had some crash problems. They went ahead and programmed a project to go in, and they put in this, right in, right outs on the two side streets. Seemed like a reasonable solution. I remember at the time working with Todd and saying, hey, what about a roundabout? But they loved the idea, but I don't think the locals did. The railroad probably didn't like the idea, so they went ahead and proceeded with this project. But over time, the problem you ran into is that they had a lot of maintenance issues for the gates that were out there. The traffic that wanted to go through the intersection had to do a right in, right out, and then had to go down. So you had to know in advance. You had to take a different frontage road to be able to get around the intersection. So Todd came back to me in 2019 and said, "Hey, do you still have that sketch for the roundabout?" And I was like, "Yeah, I think I do." And I drug it out, and essentially this put in the roundabout at the intersection, same footprint, so we really didn't expand it anymore. The crossing distances didn't get any worse for the railroad, and for $200,000, it was a fantastic project. I mean, a lot of really good work from the district to be able to get this one designed and put in place. We even got a little video here of the train that goes through the intersection. You can see as the train approaches the intersection, the gates were already down, so you've got gates on circulatory roadway before the approaches as well as on the approach roadways. And so you see like this guy stopped early back at the yield line, but he could have stopped up here at the gate. Another car stopped over here, and then once the train goes through, then the gates raise up and allows traffic to be able to go through it. And you can even see a tractor trailer comes up over here on this side, so he just does a standard yield as he approaches to it, and then the cars have their normal circulating traffic and are able to clear the intersection. It's been a great project. So now we're taking all these lessons learned from these different projects. The last one had the blisters on the outside. It was one of the ones that probably the district, you can see them on the outside corners here where they had the blisters out there to be able to slow traffic down. Well, we've got to take those lessons learned from those projects that we're putting in these features at lower cost roundabouts, and how can we apply those to a conventional delivered project to try to help save cost? A lot of it is really staging costs. The premise behind some of these outside truck aprons is you can pave the circular area, allow traffic to drive around on those outside shoulders that are paved so that they can avoid the central island while you pour the concrete in it. And then afterwards, instead of having to tear out all that asphalt you put in to put in curb and gutter and a closed drainage system, just pour the concrete on top of it. And it saves a lot of staging, gives the contractor a little bit more room to what he's got to do out there. Management, I know, had been looking for ways to try to find reducing construction. Part of what Chris had talked about as well, and Ola both, is just trying to find ways to be able to do that. So I've got a few case studies that show different scenarios where cost-saving measures were done to be able to try to reduce costs. This first one, 52 at 183. It's a little bit different than average in the fact that you had an intersection that you had this triangle area in the middle. So very similar to the first intersection we looked at 1841, where you had the central area, and it's like, can we capitalize that to be able to put in the central island? So you can see the central island went right in that space in the middle. And it's just kind of trying to apply practical design and staging thought processes to it. Now, this wasn't necessarily an inexpensive project, but you can see there's a big culvert here. They had to extend the culvert, and to be able to get everything to work out. It wasn't necessarily a low-cost project, but compared to what it would have been had they had to stage it differently and put the intersection off to the side, it was a lot cheaper than the other alternatives. This next one is 11 at Lakeview, back in District 3. The previous one was in District 1. So this one in Houston County was one of the last ones that was done as a quick response project before the budgets went up. This is one where they worked with the local government to be able to try to figure out a way to put this one in. Similar to some of the other ones where, trying to apply those lessons learned, you had a side street stop, had some decent crash problems at it, went in and basically put in a more compact size. This one's about 100 foot. They have gone back and said they really almost kind of wish that they had maybe been able to get in more of a raised element. But you can see in the center there's an internally illuminated bollard to try to deter traffic from driving straight through. But once again, they've got the outside truck aprons on the different approaches and trying to apply that lesson learned over to how it works. Now, these next couple are starting to get to the threshold where, hey, that quick response money is really starting to dry out. So how are we going to be able to implement these? 16 at I-16 at 17, Little Neck Road. I was talking with the district engineer at the time. He was trying to identify, a way to improve this. And the reason why is this large area you can see in this photograph that has all this, concrete color in here. So as State Route 17 was getting widened, this was all getting widened as a 4-lane divided roadway. But when you got down to the interchange, it dumped right back down to a 2-lane road that went over the bridge over the interstate, because for whatever reason, I think that project got delayed. They're trying to figure out a gap to be able to try to get it to work. And so analysis was done. It was determined that the roundabouts would work. I think they've got an interim project, this was just an interim project. Their project behind it is actually going to put in a DDI at the interchange. But you can see the 4-lane divided section back in here, and you had all this traffic come to these intersections. So the solution was to be able to try to fit in a roundabout at these. And I think the big thing with these is that knowing was an interim improvement, that there was going to be another project coming down the road, you could take the intersection as it was with just a side street stop on the ramp to using this very similar footprint, doing a little bit of widening on the corners to be able to put in the roundabout. But the district decided, and I think it was a good decision, that you didn't have to go in and put in the blisters on the outside. In these areas, they were able to get away with striping on the outside curbs. Because of the movements, not having movements on all 4 legs, there was advantages to either having guardrail on the outside to be able to adjust fastest path, but I think also, and you guys can drive through it on the way home if you want, you can just go through, and the striping itself adds enough of an illusion to where traffic isn't going through it as fast. And knowing that it's going to be a 4 or 5 year solution, the intent is just to have something that kind of had a Band-Aid to get you through until the DDI comes along. I think the most critical path, the one that we had the highest concern, was this southbound approach at this one. So we made sure we put in a raised element between the lanes, so it disallows someone from being able to just go straight into the roundabout, because this is actually raised here, and that was deemed to be critical. Coming from the south, you're coming across the bridge, so you just went through the intersection I'm going to show you in a second, which is the outer roundabout, so you can only have so much speed after you've gone through this intersection to get the other one. So it's, once again, when you're coming in on these higher speed approaches, getting some type of raised element, and in this case also for the exit ramp from I-16 westbound, is making sure that you had something that would actually slow them down or keep them from being able to cross over in circulatory. Not all the geometry is perfect. I mean, in a perfect world, you may not have your right turn bypass be where it is, but trying to utilize pavement, and both of these were done as essentially a use-on construction revision on the construction project. So they just basically took the construction project, kind of haggled with the contractor, and got them to do work outside of the original project limits to be able to implement these 2 improvements. The next one's 257 at Pine Hill. This is a really great one in District 2. Also, once again, you got the interstate right up here, so this intersection was seeing issues that needed to be resolved. How could they implement the improvements out here and try to keep the cost of the project down? This was a lot of really good decisions that were made on the district level. I've got a little video here that shows the simulation of the intersection. So they kind of went in and said, okay, as you're going through this intersection, we're noting where we have different constraints, and you've got parking lots on different sides and all that are causing those constraints. So what can they do? And so it was deemed that, hey, to try to keep our footprint smaller, let's use some of those raised elements at the intersection. And so you can see here, here's what it was before. It was side street stop, and going in afterwards, this is one I had on the entry slide, where they used the outside truck aprons as elements to be able to keep the footprint small, not have it have a closed drainage system, be able to keep it as an open drainage system. So ended up being a great solution, and a lower cost delivery than what it would have been if it had all the closed drainage systems, all the curb and gutter around the perimeters and all that. The last one I'm going to show you is State Route 2 at Crow Road. So this one's in District 6. This is one where Chris and Mike Ovis, I think both, had kind of come to us and said, hey, we really need to try to do something at this intersection. The biggest thing is you've got a school back in here, a lot of pushback on trying to do anything out there. The intersection itself, this is what it looked like. They had done projects in the past to be able to put in all this extra capacity out there, but it still didn't mean that it met signal warrants, because all your demand was when school was letting out. It wasn't necessarily all day long. But I mean, this was one that you guys were getting calls constantly on. And so what we did is we went in and looked at, well, let's try to fit in a roundabout at the intersection. We had a little bit of extra right of way on the corners, try to fit it in. Now, at this stage, the quick response budget had gone up to $500,000. We're like, oh, that's tons of money. We can fit in whatever we want to. But when we started putting together cost estimates for it, because it had curb and gutter all the way around the perimeter, it still ended up getting the cost just a little bit too high, just above this, I think it was close to $600,000 limit. And so we went in instead and just put in these outside blisters on the sides. Actually, we were able to use some of the guardrail as some of our control criteria for keeping speeds down with rumble strips on them. And this lower cost solution ended up just got let out to bid, and it was I think the way this one worked was it came in a little bit over $500,000, but you guys were able to basically approach the lowest bidder, which is like 550 or something like that, and then you guys did the signing and marking on it to be able to get the price down. So, but just from what Mike Govis's estimates were, is probably saved $100,000 just by removing the curb and gutter and the closed drainage system that would have had to go out there. So, quick response roundabouts are back alive again. So, decent size roundabout out here. So, I think that's the last slide I have. I guess Mojtaba, we're open for questions for everybody.
Thank you, Scott. Thank you, Ola. Great presentations, and we're doing good on time. So I guess we could have a few Q&A at this time. If anybody has a question, there's a microphone over there. Or if they're not talking to the microphone, if you could repeat the question before answering it, would be awesome. Mario.
I can yell, I think. So this question's for Ola and Scott. The roundabouts that you were showing, were mostly what I saw was 5 or 6 years old. And those costs are dramatically less than what we're experiencing today. Like OPD is saying anything under $4.5 million, they just toss in that. So how would you suggest design balances practical design versus the evolution of the roundabout design and the overall cost?
A lot of the original low cost ones that we demonstrated were really just to try to demonstrate that, hey, you can find lower cost ways to do it, like putting the outside buffers out there. Yes, OPD is going to tell you if you've got a full-size roundabout and it's got closed drainage systems and everything else that's in there, they're going to want you to be 3.5 million or whatever it's going to be. I think you could go back and push back on that and say, well, this one is a rural practical design. I mean, I'm looking at District 2 because they're the ones that really push this through management, and management's fully aware of that. I mean, this went all the way up to Andrew Heath, and they've pushed down. This is what we need to do to try to keep costs down. And so you can go in and say, hey, look, staging is going to be easier, construction's going to be easier, so you can trim off maybe $1 million off that number by using practical design. The biggest bulk of savings is going to be in staging. That last example that I showed, the one at 2 Crow Road, is from literally 2 months ago is when they got bids on it. So $500,000 to put in 125-foot inscribed diameter single lane roundabout. Now, it's not a multi-lane, it's not conventional PDP. You probably double or triple that price for a conventional PDP by the time you do anything, if not more than that. But I do think you can push back. I do think it's possible. So, but I think it is important that you explain to the OPD PM or to whoever it is when they're programming it, it's that key word. You're probably going to need to say, this is a practical design rural roundabout. It's not urban. We've compressed the size of it, those type of things. You're going to have to use those trigger words. But I think if you use those trigger words, then that OPD PM or OPD management should be able to respect that and say, yes, this is exactly what the district asked for, so therefore we're able to keep costs down.
And I guess I could just add, your initial cost estimate might play a key role in being able to convince that narrative that, hey, we're looking to do something a little bit more practical, and as an early assessment, we're looking at a $2 million job without curb and gutter, things of that nature. So having that in your back pocket would help.
Thank you, gentlemen. If there is any, yes, sir, go ahead.
Quick question for young lady. You have some nice research statements there on your pedestrian issues with the roundabout. Does GDOT consider those statements, and are they going to take them to TRB for consideration of future research projects? I think you did a marvelous job, young lady.
Can you hear me? Okay.
There we go.
How about now?
It's on. A little closer.
How about now? Oh. Our goal would be to do more research into this. We want to answer those questions, and we would love to work with GDOT on answering those questions. And well, GDOT and honestly nationwide as well. This presentation also was done for TRB this year as well. So bringing.
Good questions for NCHRP to be looking at. And I've served on a bunch of TRP panels for things, and your questions look like really worthy of going through their review process for research projects.
Yeah, that is absolutely our goal right now. Just trying to bring awareness to the issue to get some of that further research done.
I think that's really good questions.
Thank you.
Any other questions?
I would imagine those roundabouts that you were talking about, Scott, that you probably save a lot of money on lighting and landscaping, correct? You probably just use some existing lighting or something like that on your low-cost roundabout.
A couple of them had, like you said, existing lighting out there. Most of them, if they had landscaping, it was the low-cost landscaping approach, where it's just GDOT standard landscaping that's out there. But a few of them also had lighting. The one for Two at Crow has full lighting, full landscaping, mounting of the central island, everything for the $500,000 on that one. So realistically, unless if it's a temporary roundabout and you get some type of special stipulation, you're probably not going to be able to not have lighting out there. You just have to prove you have acceptable lighting levels existing. So.
Go ahead, Catherine.
My question is for Chris. How would large vehicles like tractor trailers or water buses benefit from the Fetch Super Spiral Roundabout?
I mean, I'm not sure they would exactly benefit from it. They just wouldn't be necessarily hindered by it. I mean, again, talking about the traditional multi-lanes with those really swoopy entries that are required without raised elements. Swoopy, yeah. So really, it honestly ends up being a little easier to both get truck accommodations in lane and keep speed controls in check with the raised elements in the middle between the two lanes. Because you can kind of come in a slightly more, a slightly less swoopy entry, and then they can navigate the roundabout just fine. And if need be, I mean, there are just 3-inch curbs. I mean, the same height as the central island. We don't necessarily want them to have to, but they are mountable as well.
Designed for staying lane.
Mm-hmm.
They're designed for staying lane.
They are designed for staying lane, but yeah, the truck won't, flip over.
Excellent, thank you. Any other questions? No question 1, no question 2. Okay, the last. The time is done. One quick thing, I was curious, I wanted to ask Chris if there is any turbo roundabouts in Georgia, or if we're planning to build, or how many?
You mean like full-on Dutch
Yes.
turbos? I don't believe we do. I mean, he's the man to talk to.
How many are there in the whole, like, in the U.S.? 2 or
US,
3 maybe?
not more than a handful. Yeah, there's one in California that's a full 2x2 turbo. I really think they were trying to rip off my super spiral idea, but it's not nearly as good. And it looks really ugly, in my opinion. That's professional opinion. But no, there aren't a lot of full. But I mean, the feds are kind of pushing that at this point. But I don't know. I'm really hoping we get more of our designs down that kind of combine traditional roundabout design elements with turbo elements.
Yeah.
And I mean, obviously, it's just my feeling, but I think they're going to work well, and I think people will start wanting to do that more places across the country.
Well, thank you, Chris. They should definitely feel like that. Okay, well, if you could have a round of applause for these panel. Thank you.